Okay, so I'm not going to do every single question here, so I'll do like half because it's not that difficult. So again, if you're doing all those multi-step equations, this should be a piece of cake. So I'll start with the first one. So here we go, and then I'll write it over here because there's the form. So it's negative 12 greater than x minus 7. So we're going to treat this as a one-step inequality, right? So if you do your little story, you can ask yourself, here's my variable x minus 7, and that's less than negative 12. So again, the inverse operation that we're going to use is plus 7. So just like we did with equations, we can like divide the side into left and right. We do plus 7 over here, plus 7 over here. These two cross it out because it's 0, right? So again, the greater than, and then x is left over on this side. And negative 7, negative 12 plus 7 is negative 5. We have to graph this. And when we graph this, we'll put negative 5, and then we'll put a couple of numbers on the right side, and some numbers on it. Put a circle. Well, it's not shaded because if we put negative 5 in here, in here, can we say that negative 5 is greater than negative 5? It's not. So negative 5 is not part of the solution. So now we gotta fix. We gotta point the arrow either to the left or to the right and figure out which numbers can I replace the x with and to make this inequality true. So again, if you don't know, I highly suggest pick a large number, 1,000, and just for a second, we put it right here instead of the x. So let me put 1,000. And ask yourself if that makes sense. Is negative 5 greater than 1,000? Obviously, it's not, right? So if it's not, and this tells you that numbers, and ask yourself, where is 1,000? 1,000 is on this side, right? On this side, the right, not on the left. So any number to the right, it's not going to work. So pick another one. I mean, and I'm going to erase the 1,000 and pick 10, which is also on the right side of the circle, right? It's on this side of the world. Is negative 5 greater than 10? No, it's not. So again, this is telling you that numbers on the right sides are not going to work, but numbers on the left, these numbers are going to work. So any number to the left of negative 5, when I replace it in the original equality, will make that inequality true. So let's do a check here. So I'm going to do a check. And to do a check, we copy the original equality, right? And I'm going to pick x equals, and I'm going to pick a negative 20 for example. So I'm going to pick a number to the left of negative 5, and that number is negative 20. I'm going to replace it here. So instead of x, so I'll write the x out. So I'm going to replace that x. I'm going to go negative 12 greater than, and I'm going to replace that with negative 20 minus 7. Negative 12 is greater, and negative 20 minus 7 is negative 27. Is this true? Is negative 12 greater than negative 27? Yes, it is. If you put these two numbers on number line, here would be 0, right? And we're going negative 12, 13, 14, 15, and negative 27, right? So how do I know which of these two numbers is the bigger one? Well, the number on the right, which is this guy, is always the greater number. So in this case, negative 12 is greater than negative 27. Yeah, that's it. I'm going to pick and choose a couple here and there. Let's do one. Let's do 3. So I'm going to do it over here, actually. N minus 6 less or equal to negative 14. Do a little story over here. My variable is n. Minus 6 is being subtracted. Less or equal to negative 14. So the inverse operation I'm going to do is going to be plus 6. And that's all I have to do. So I'm going to do plus 6. I'm going to do plus 6. These two cross out. N is less or equal to negative 8. I'm going to graph this. I'm going to put negative 8. I'm going to put one number here, negative 7, negative 6, and over here, negative 9, negative 10. Negative 8, shade or not shade? Well, it has an equal sign, so I know it's going to be shaded, but it also means that if I take this n over here, just for a second, if I took this n and I put negative 8, well, that statement would be true. Is negative 8 less or equal to negative 8? It is. So guess what? Negative 8 is part of the solution. So if I replace negative 8 here, it does work. So that's why we shade it. So negative 8 is part of the solution. So now I got to figure out what other numbers are also part of this. Will make this inequality true. So all right, numbers to the left or to the right of negative 8. So again, if you don't know, I highly suggest you pick a number. Like I said, pick 100. pick 1,000, pick 1,000,000, exaggerate on the numbers. So if I replace the n with 100, I have 100 less or equal to -8. That's not true. If I pick 1,000, is 1,000 less or equal to -8? Also not true. Where is 100 and 1,000? They are numbers on this side, right? On the right side, right here. So all these numbers on the right side will not make this inequality true. So I gotta point it this way. Okay. So now I do my check. To do my check, I copy the original. N minus 6 is less. That was my original inequality. I'm gonna replace this n here with something, and I want you to choose any number that's over here to the left of -8. So let's say n equals -10. So I'm gonna use that number to check. So let's put that. So I take the, again, I guess let me just write it. So here's my original inequality, right? I'll replace that with -10. Now I'm gonna combine these two, and I get -16, which is less than -14. Is that statement true? Yes, it is. Okay, so we know our problem is correct. So again, we can pick any number, or you can pick any number that's on the left of -8, including -8, and that will make that inequality true. That was 3. Let's pick something with multiplication. Number 9. So number 9, we have, again, let's start with a little story. We have a variable x, which is being multiplied by -3, and that gives us 3. Going backwards, we're going to do the opposite of multiplication, which is divide by -3. Alright, so let's get to it. So let me copy that problem over here. -3x is greater than 3. Draw a line here in the middle. I'm going to divide this side by -3. I'm going to divide this side by -3. -3 divided by -3 is just 1. 1 times x is x. On the other side, 3 divided by -3 is -1. Remember, when we divide by a negative number, remember the multiplication property of inequality. Inequality property of multiplication. Sorry. It says that when we divide or multiply by a negative number, we have to do something with the sign, which means we have to switch it the other way. Okay, so that's the one thing we have to really be careful when we're dividing and multiplying. If you're multiplying and dividing by a negative, switch the sign. So now I can graph this. Here's -1, here's 0, here's -2. Here's 1, here's -3. So I'm going to put a circle on top of -1. And ask yourself, let's put -1 here. Is -1 less or equal to -1? No, it's not. So our circle will be open. We're not going to shade it. Now we got to figure if it's going to be numbers to the left or numbers to the right that's going to make that inequality true. Well, again, pick a number. Pick 100. Is 100 less than -1? No. Pick 1,000. Is 1,000 less than -1? Also a no. And where are those two numbers? Those numbers are on this side of the world, on the right side. So we don't want the numbers on the right side. We actually want the numbers on the left side. Okay. Now we have to do our check. So we're going to copy the original inequality. And then we're going to replace that x with any number of your choice to the left of -1. So pick one and tell me which one. So I'm going to say that in this case, x equals, I'm going to pick a -10. So I'm going to replace that x. I'm going to go -3 times -10 is greater than 3. Well, it's a negative times a negative, so that gives me a positive. 3 times 10 is 30. And 30 is greater than 3. Is that statement true? Yes, it is. So my check is good. My solution is good. My graph is good. Done. Let's do one with multiplication. Let's do number 11. So number 11, again, let's start with our story. Okay, so we can start with a little story. So number 11, we have a variable k, which is being divided by 4, right? That's what it says. That's less than -4. Going backwards, we're going to do the opposite division, which is multiplication. We're going to go times 4. And that's what we're going to do. So let's do that. So k over 4 less than negative 4. So the first thing we want to do is multiply each side by 4. Multiply this side by 4. Multiply this side by 4. This 4 and this 4 cancels out, right? Because 4 divided by 4 is 1. And 1 times k is just k. We're not multiplying by a negative number, so our symbol stays the same. And negative 4 times 4 is negative 16. Draw a number line. Negative 16, negative 15, negative 14, negative 17, negative 18. Put a circle. We know it's not shaded because there's no equal sign. And we also is not shaded because if I replace k with negative 16, so let me put negative 16 here for a second. Is negative 16 less than negative 16? No, it's not true. So therefore, that circle is shaded. Now, what numbers will make this inequality true? What numbers can I replace the k with so I can say that it's less than negative 16? Numbers to the left of the circle or to the right? Again, let me pick a number to the right of the circle. And again, negative 15, negative 14, I can pick 0, 10, 20. Let me pick 50. 50 is less than 16, not true. Pick 40. 40 is less than 16, not true. So 5, pick the number 5. Is 5 less than 16? Not true. So again, by now, after all those 3 examples, you can tell that numbers on this side here are not going to work. So we want numbers on this side. Your check. The original inequality is k over 4 less than negative 4. Let's pick a number over here on the left side. It's divided by 4, so I'm going to pick a multiple of 4, so that makes my division easier. So I'm going to pick k equals, and on the left side, let me pick negative 20. Now replace that, so I'm going to get negative 20 divided by 4 less than negative 4. And what's negative 20 divided by 4? Well, first of all, it's a negative divided by positive, which is negative. And 20 divided by 4 is negative 5. So negative 5 is less than negative 4. And that's completely true. So it seems that I did the right thing. So my check is okay, my number line is okay, my graphing is okay, and my solving is okay. Let's do 12, because 12 is a little bit different as well. Not 12, because that's a repeat of a. So let's do. So number 9 and 12 are very, very similar. Well, I think we're good. This is 6. So 6, here's my variable, which is x. What's happening to my variable is plus 15. Gives you a 0. Going backwards, the inverse operation I'm going to do is minus 15. So let's do that. So I get 15 plus x less or equal to 0. So let's subtract 15 from both sides. Subtract 15 from both sides. Minus 15, minus 15. These cross out. X is less or equal to negative 15. Wow, all of our answers have been negative. Let's graph that. So it's negative 15, negative 14, negative 16, negative 17, negative 13. For a circle? Less or equal, right? So I know we can shade this. And you also can shade, the reason we're shading this, because we replace this with negative 15. Negative 15 is not less than negative 15, but negative 15 is definitely equal to negative 15. So negative 15 is part of the solution. It's one of the numbers that will work if I replace the x, right? So now what other numbers work? Will be the numbers on the left side of the circle or the right side of the circle? Well, let's pick some numbers. And like I said, pick some numbers, usually positive numbers, large. Pick 1,000. Is 1,000 less or equal to negative 15? No. Pick 10,000. 10,000 less or equal to negative 15? No, it's not. So, is 10 less or equal to negative 15? No, 10 is not less. It's greater. So you notice that numbers on this side, right side, do not work. So which numbers we want? We want the numbers on this side. We solved, we check. We solved, we graphed. Now we got to do a check. So on our check, we take the original inequality, 15 plus x, less or equal to 0. And we're going to pick a value on the left side here, negative 15 to the left, so pick anyone. And let's just pick x equals, in this case, let's pick negative 15 because we're allowed to pick negative 15. So I'm going to replace the x with negative 15. Let's see what happens. So 15 plus, replace the x with negative 15, less than 0. 15 plus negative 15 is just 0. So it's 0 less or equal to 0. Yes. So our check is good, our graphing is good, and our solving is good. And that should be more than enough for you to have as guides to do that first page. Okay? And that's that.